Alright, ladies and gentlemen, welcome to my video. In this video, I'm going to be going over object-oriented programming in Kotlin. In the previous Kotlin tutorial, I went over the basics of Kotlin, and I'll leave a link in the description to my blog post for that, as well as my playlist to that. But in this video, I'm going to be going over the concepts of object-oriented programming in Kotlin. Object-oriented programming is a concept that uses classes and objects to store and manipulate data. This data is stored in the form of fields, such as attributes or properties, and methods. Methods are just functions within the class. So we're going to dive in a little bit deeper upon that. And the first thing I'm going to talk about is classes. Alright, so a class is a blueprint to create an object. So if you guys can see from my very amazing drawing, you can see that we have a house. Alright, we can have different properties for a house. So that's what the blueprint should describe. It should describe, the amount of rooms, the amount of bathrooms, the color of the house. These are properties of a house. These are the things that a blueprint should have. Alright, and then we have actions. Alright, this is going to be the methods of the object, the things that the house can do. So we can open the door, we can close the window, we can paint a new color. These are the methods of an object. This is going to be the functions that you have within a class. So I hope that helps clear it up a little bit. A class is a blueprint of an object, and a class contains properties about the object. So in this case, the object is the house. You guys can see the windows, you guys can see the doors, and on a deeper level, these properties describe the amount of rooms, the amount of bathrooms, the color of the house, and it can do actions, or a object contain methods, or a class contain functions that is called the method when you create the object, which in this case is a house. You can use it to open up the door, you can use it to close the window, and you can even paint a new color. That's cool. So now we're going to see in Kotlin how to create this blueprint. So if we switch over, see how to create this class or this blueprint in Kotlin. So as you guys can see, I have this main function, and really this is already going to be in the application start file. I'm going to keep the class in the same file, but later on we're going to write its own file for it. But in this case, I'm just going to put it right below the main function, and I'm going to put class, and in this case I want to create a house. And then you open up some curly braces, and within these curly braces, this is where we're going to start writing some properties to describe the house, or create some functions to describe an action that the house can do. But another cool thing about Kotlin is that if you have no properties that you want to use to describe the class or the object, you can just omit the curly braces, and this will just signify that it's going to be an empty class. And this is perfectly fine. This is still a class. But in our case, we want to actually write some properties about the house, so we're going to do that. Before we start creating properties, we should first think about how we're going to pass data to those properties. If you think about a blueprint is not usually used just once. Usually it's used multiple times so that you don't have to keep creating multiple blueprints. That saves time. But there has to be a way to make the house a little bit different. So maybe we might change the amount of rooms. Maybe we might change the amount of bathrooms. Maybe we might change the color just to make the house a little bit different. But how are we going to pass this different data to the blueprint or to the class? In our case, we're going to use a constructor. Constructors are used to pass in data when an object is created. In our case, a house. So when a house is created, this is how we're going to pass data into it. In Kotlin, we have different types of constructors. We have the primary constructor and we have the secondary constructor. You can only have one primary constructor, so I like to call this the base constructor. But you can only have one primary constructor, but you can have many secondary constructors. And in Kotlin, we still have constructor overloading. If you guys programmed before, constructor overloading is when you're writing multiple constructors, but the parameters are different. They can't be the same, because that would be counterintuitive if each constructor had the same parameters. We can use different amounts of constructors to specify what parameters that you expect. So maybe we just want the user to pass in rooms. We can have constructor for that. Maybe you want the user to pass in a room and the color of the house. You can have a constructor for that. So constructor overloading allows you to have multiple constructors to allow for different parameters to pass in data. So the primary constructor, let's start that off. To create a primary constructor, all you got to do is place a parentheses right after the name of the class. Boom. And we can start writing parameters that we want to pass into this house class, or right into the blueprint. You also have the option to write out the actual word constructor and then place the parentheses right after that, but that's optional, and honestly I don't like doing more work than I have to sometimes, and in this case, if it's not necessary, I can omit it. Before we talked about rooms, we talked about bathrooms, and we talked about color for the house. So let's add that as the parameters. So let's add rooms. I'm gonna make that an int. Let's add bathrooms. I'm gonna make that a double, because sometimes, you know, some houses, you know, they can have 2.5 bathrooms because, you know, one of the bathrooms don't come with a tub. And then we'll add color, and this is gonna be a string. And boom. So now when we create a house, we expect the user to pass in rooms, the amount of rooms, the amount of bathrooms, and the color. So for a site like Zillow, on a very basic scale, this is perfect. And for the primary constructor, we can even have default values. So if you think the user is gonna put something sketchy, or they're not gonna put anything at all, we can, you know, put in some default values, and, you know, if they don't put anything in, then we'll just use these values. And then for string, we can place that. We can put empty string. But in this case, I don't want to do that. You know, I want the user, I want to force the user to place in data when they create this house. The next type of constructor that we have is the secondary constructor. Now, to create a secondary constructor, you actually do have to use the constructor keyword, and in this case it's not optional, but it's in a different place now. It's within the body of the house. So you just type in constructor, and then you open up parentheses, and it actually comes with a body. So if you want to run some code after the user passes in data, you could. And just like the primary constructor before, you just place data within the parentheses. So in this case, I could also put rooms, and I could put int. I could put bathrooms, and I could put double for that. And then I can put color, and I can make that a string. So yeah. And then I can print ln, and then I can print out some, or I can print out the color. So I can just literally just put color and color, and boom. So when a person creates a house, and we're gonna show that later on, when a person creates a house and they pass in the room, bathrooms, and color, this will run right after. So it'll take the color that is being passed in, and it will print it out. So that is the secondary constructor. So we're not just restricted to just using, you know, the secondary constructor individually and the primary constructor individually. We can use both of them at the same time. So let's see that in action. So currently we just have the secondary constructor. Right now there is no parentheses after the class name, so that means there's no primary constructor. But if we add a parentheses right after, we're including the primary constructor. But as you guys can see, a red squiggly line starts to appear. It says the primary constructor call is expected. So when we add a primary constructor and we have a secondary constructor, it still expects us to call the primary constructor first. It should be the first constructor called when the object is made. To include the primary constructor, we just add in a colon right after the parentheses in the secondary constructor, and we use the keyword this. Oh, that's not how you spell this. This. And this pretty much means that we're going to make a call to this primary constructor, and you have to add a parentheses right after this. And this will make a call to the primary constructor. Right now we have no parameters in the primary constructor, so we don't have to include anything within it. But if we were to have something like color, so let's put color string. Now it expects you to pass in a parameter to this primary constructor. Even when calling the secondary constructor, we still expect to pass the parameter to the primary constructor. So to do that, we're taking color in the secondary constructor. We could just take that color variable, which is right here, and we can just pass it to the primary constructor, and that should cause the squiggly line to go away. So that's how you make a call to the primary constructor even when using the secondary constructor. And let's do a little example, because we're always talking about passing in parameters or passing in data, but we don't even know how to do it. So just to show you guys how to pass in values, let me just put a tab. Let's call val, and we're going to call this house. We're going to make this equal to house, right? We're going to open up the parentheses, and now we're making a call to constructor. See, it's giving us two options. We can either make a call to the primary constructor, or we can make a call to the secondary constructor. In this case, I want to make a call to the secondary constructor, so I'm going to pass in the amount of rooms. So I want a 4-room house with 5.5 bathrooms, and I want the house to be blue, you know, very mellow. And if I run this with a little bit of time, you guys will see, boom, color is blue. So pretty much we're creating a house. We're using this parentheses to call the constructor. We're choosing the secondary constructor based on the parameters that we passed in. It's saying that we have an int for rooms, a double for bathrooms, and we have a color for string. And first, when even though we're passing this data to the secondary constructor, it's still taking the color that the person passed in, which is blue, and it's making that call to the primary constructor first, and then it's going to run this println color, and then the color that the person inputted into the constructor, which is blue. So the primary constructor comes first and the secondary constructor comes last, and there's something in between that we're about to talk about, which is called the init block. Before I show you guys the init block, I want to show you guys that you don't necessarily have to call the secondary constructor. You can also just go by the parameter of the primary constructor, which in this case is just accepting a string for the color. And if we put red and we run that, we can see that the secondary constructor doesn't even get called. There is no printout. It doesn't even touch this. It just gets that value, and that's it. The primary constructor just retrieves the value. But what if we want to hold on to that value? How do we do that? We're gonna need class properties for that. So to use class properties, or to make class properties, we just create variables for it. So in this case, we're gonna have a variable that holds color, and we need a place, or actually let me just make this a string, right? And now we just need a place to initialize this data. We need to get the values or the data that the person is putting in, and find a way to pass that value to the class properties. So it says property must be initialized or be abstract. In this case, we want to initialize it, so we're going to use a thing called the init block. All right, this is where we're going to initialize the class properties, and it's just using the init keyword, and we open up a body using the curly braces, and then now we can pass in data to the class properties that we have above, or class property, because we're just using one right now. And within this init block, we can run any code. We can print, we can, you know, store values, we can make another variable. But for this case, I just want to take the value that the user is passing in, and I want to pass it to the class property. So the first thing we're going to need is this, because the fact that I made this property called color, it could probably be confusing for, you know, people that's going to view my code. So I'm going to use this keyword to signify that I'm taking the property of this class, which in this case is going to be color, and I'm going to make it equal to color. And you guys can see the squiggly lines go away, or the red one goes away. But yeah, I'm going to take this property of the class called color, and I'm going to make it equal to color, which is going to be the color that the user passes in through the constructor. And there's an order to this thing, right? So the order is the primary constructor is called, then the init block is called, and then the secondary constructor is called last. So I like to think of the init block as the body for the primary constructor, because as you guys can see, the constructor has its own body. right? But the primary constructor doesn't have its own body. We have to use the init block to initialize the data, so, or to run some code if we wanted to. So that's what the init block is good for. You can run some code or you can initialize the data if needed. So just to show you guys that the init block is actually receiving the value that we're expecting from the user, we'll just use the println in the init block, and this is ran after the primary constructor, like I said. So we're just going to pass in this dot color, and we're going to run this, and we should expect to see red. All right, cool stuff. So now we're not just restricted to just using one init block. We can use multiple init blocks. So if I just copy and I paste this right under, and I'm going to add in another class property. So I'm going to call this one rooms, and I'm going to make that into an int, and we're good to go. It's going to have the same problem. It's going to say that this property must be initialized. So I'm going to just use this dot rooms, and I'm going to make that equal to rooms, and I have to add that to the primary constructor, and I'm going to print that out as this dot rooms. And let me just add this to the primary constructor. So then it's going to be rooms int. So now you guys can see that the parameters changed in the primary constructor. So I have to add this, I have to pass it to the primary constructor in the secondary constructor. So we're going to take that rooms and pass it to the primary constructor. And now it's letting you know that you got to choose between using 2 parameters or using 3 parameters. I still want to use the primary constructor, so I'm going to use the 2 parameters. So I'm just going to pass in 2 as the number of rooms that I want. And if I run this, I should see red and I should see 2, which is exactly what I see. And which one runs first just is based on what order you actually put the init block in. So it's going to run the color first, and then it's going to run the rooms after. But if I just take this and put it right above this color init block, and I paste it there, and I run this, boom, 2 and red. So this shows, you know, how powerful the init block can be. And if you want to keep things short, maybe you want to keep it, you know, in a small context, maybe you'll use multiple init blocks. But you know, it's possible if you need to. So before I talked a little bit about constructor overloading. So let me just copy this so you guys can see exactly what it is. Let me just copy this, and then I'll paste it right under it. Right now it's going to show an error saying conflicting overloads because we have the same amount of parameters, and that's redundant. But all you got to do is either add a parameter or take out a parameter. So in this case, I want to keep color and rooms because I know we have to pass that to the primary constructor. But I want to add in another parameter called the HOA fee. Now, this is the house owner association fee. You know, so it may be 0 or it may cost something based on the place of, you know, of the house. So if it's in the community or something, you might have to pay a fee. And we're gonna make this a double because we're talking money. And the primary constructor, you know, maybe we don't need that. Maybe we don't have to pass that value. But if the person does pass in the value, then we're talking about this constructor. So now we have multiple constructors. We have one that takes in rooms, you know, bathrooms, color. Then we have one that takes in, you know, the same thing as above, which is rooms, bathrooms, and color, but it also takes in the HOA fee. But the primary constructor only cares about the colors and rooms. So we still have to pass, you know, color and rooms to the primary constructor, because no matter what constructor we use, even if we're overloading constructors, we still have to make a call to the primary constructor using the parameters that they expect. But now let's pass in the amount of rooms. So I want to make it 4 rooms this time, and I want to make it 5.5 bathrooms. The color is still going to be red, but I want the fee to be $500, and we got to put it 0.0 because it's a double. And if we run this, let's print out the HOA fee so you guys can see that it's actually getting there. And if we run this, we should still expect the init block to run, because it runs right after the primary constructor and then the secondary constructor runs. So let's see that in action. Actually, let me change this to HOA fee. And let's run that. Boom. So we see the amount of rooms, we see the color of the house, and now we see the HOA fee. We don't see this color because of the fact that we're not calling the secondary constructor, but we are still getting to this secondary, or we are still getting to this init block, or these two init blocks, because we call that no matter what right after primary constructor. And then we're getting to this last constructor because of the fact that we use different parameters, so we don't even touch this constructor that uses 3 parameters. We use the constructor that uses 4 parameters because we passed in 4 values. So makes a lot of sense. And we're still able to store that value because we're passing the color and rooms to the primary constructor. So then it's just taking those values that you pass to it, and it's using these init blocks to initialize it. So that is the power of the blueprint. That is the power of creating an object. And that is the power of constructor overloading. Alright, so now let's start defining behavior for this house. So to define a behavior, we can use a method. A method is simply a function that is associated to a class. So all methods are functions, but all functions are not methods. So let's take a look. We're going to create a prompt because maybe if we're a real estate agent, we want to be able to give a small description to a user about how the house looked like. So we're just going to go by what we see in the primary constructor, which is the color and rooms. We want to let the user know, what this house looked like in a nice, neat prompt. So to create a method, which is just a function associated to a class, we simply just use the fun, which is, to create a function. And then we're going to make a simple prompt. And then we're going to open that up. And we're just going to use the properties that are already defined in the class, because we know we're going to need to pass in color and rooms when we create an instance of a house. We know that's available to be used. So we can just have a print, and we'll just make a message. So we'll just say the color of the house, I can't spell today, is, and then we'll just pass in the color variable using the $, and then put in color and the amount of rooms, and then we're just gonna put like a little, and then we're gonna put rooms. I just put a little colon there. So now we have a simple prompt defined in our class. Now to use that behavior, we have an instance of a house stored here in this variable called house. So to make a call, we just take that instance of the class called house. We use a dot, and you guys can see what are available from this instance of this class, or from this object. So now we can see the simple prompt. We want to select that, so we just use a dot. We get that simple prompt method, and we pass in the open parentheses. Usually if you want to pass in parameters, you could, but since we're not taking any parameters, we just leave those blank. Now if we run it, and as you guys can see, the rooms is going to be 4, the bathrooms is 5.5, the color is red, and the house association fee is $500. If we run this, you guys will see that boom, the color of the house is red and the amount of rooms is 4. So it is unique to the object that we created. So you guys can see that we're creating a prompt based on the color and rooms that we passed in this constructor, and we're using those values to make a simple prompt. And if you want to make things more different or specific, you can also start adding in parameters or do different things like that. So if we want to do that, we can just do another one, and we can't overload that, but we could create another name. I'm going to call this medium prompt, You know, before it was a simple prompt, now it's a medium prompt. And we could pass in some values. So let's see. And we can pass in maybe a boolean. So we're gonna have a variable called includes pool. We're gonna make this a boolean, and we're gonna do this, and then we're gonna pass in includes pool. Now we just use that same object and then call medium prompt, and now it's expecting a parameter. We're gonna just pass in false because this house doesn't include a pool. And if we run that, and let me to make this a little bit cleaner, and then we comment these out and these. I have a lot of prints, so we should only be expecting 2. And let me use ln here and ln here, so they'll be on separate lines, and run that. So boom, the color of the house red, and the amount of rooms is 4, and the color of the house, again using the same prompt, but we now had an additional parameter that asks whether it includes a pool, and above here we said that it's false by passing in the false value in the parameter, and boom, and it includes pool, and that is false. It does not include a pool, so you're gonna have to go to the lake. So that is how you create methods in Kotlin for a object. It's simply a method is simply a function within a class that is it's associated with a class. So in this case, these prompts are associated with the house class. So these are the methods. Hope you guys enjoyed that, and hope you guys understand what a method is. Alright, so just for a little bit, let's dive in a little bit deeper into Kotlin. So if you guys ever had any experience with a programming language like Java or any other object-oriented programming language, you probably know that when you create a property in a class, we would have to create a getter or setter to retrieve a value from an object, or to set a value to an object, or to provide a new value to an object. In Kotlin, this is auto-generated, and if you guys never had any programming experience before that and you don't know what I just meant, let me show you guys what I mean. So we have this instance of a house, right? And we set the value to green for the color, and we set the value for rooms to 5. So now if we want to get that value, all we got to do is use the variable that's holding that instance of that class or the object, and then we just do dot color to get that value. All right, and if we run this, we should expect to see green. Now if we want to set that value, which means to assign it a value, we can do that too. I can change this to red if I want to. All right, and let me print that out just to show you guys. So if I print out house dot color and I run this again, boom, green and red. And that's because this is also a var, so it's mutable. That means I can change it. But that's how we set the value. This is a setter, and when we're trying to print it out, when we're using the dot color, we're not assigning a value, we're just getting the value. So these are setters and getters, and under the hood, Kotlin is generating that for us. In previous language and other languages, we would have to define functions to set a value, to assign a value to a variable or property. We will have to have another function to get that value from the object. But in this case, we're able to just set and get, because Kotlin does that under the hood for us. It's auto-generated. Now, the cool thing about Kotlin is that it does give us the option to change that if need be. If we want access to those functions, we do have access to it. Now let me show you guys how to do that as well. So if I go into this house class, right, and I put get, well, you guys already see IntelliJ is already giving me clues, but if I put get and open close parentheses, and I make that equal to, let's make this equal to black, right? This is pretty much just saying that every single time I try to retrieve, this property, or try to get the value of this property, I'm gonna make this equal to black. Now if I run this, no matter how many times I set it to different things, so here I set it to green and here I set it to red, when I run this, what you guys think is gonna look like? It's gonna be black twice, because whenever I try to get the value, right, I'm assigning it to black. I'm making it black. So no matter how many times I try to set it, it's gonna be black. Now by default, it's usually just gonna be filled, and this is the variable name that they use, but it's filled. That's why filled is not assigned anywhere, but it still works because this is what's holding the value that I'm setting. And whenever I use that get, now if I run it again, it worked like it did before. Filled is pretty much just holding the values that I set, which is green and red. Now I also have the option to adjust the set function. So we just saw the get function. Whenever we try to retrieve a value, this is what's being returned. This field is being returned. Now, where's that field variable being changed? Where's this data coming from? So if we do a set, and as you guys see again, IntelliJ is giving me clues, and we have this parameter. This is value. This is the value that we're passing in. So in this case, it'll be red and green. This doesn't have to be the word value. It can be whatever we choose. We can use data as well, and then we can open up some brackets, and then here is where the logic is going to be. All right. So here we use the variable name field, just like the field here. This is why it knows what field is, because by default field is used in the set function, and we're gonna make that field equal to data. So this is how it knows, like, all right, we're passing in a value that we want to be set, so we're making this equal to red. This red goes to here. It's now red. Data holds that red value, and we're setting the field equal to red. So this data is the same thing as red because it's being passed in, and now field is equal to red. So then whenever we try to get something, fields, the current value of field is red, so it's gonna get that red value. But we can also do the same thing here. What if we don't pass in data that the user is trying to put in? We can also we can make this purple, and whenever we do the set, we do have to initialize the value here, so we can just make this an empty string, but then that will all be changed when a set is done and when a get is done. So if we run this, we should expect to see purple, because look, whenever I try to do a set, right, no matter what the person passes in, I'm just gonna put purple. And now that this field value is equal to purple, whenever I try to do a get, it's just gonna take this field that I'm assigning the value to, which is purple. So it's always gonna be purple. So in a cool sense though, we could add some logic to it. So here, let's do a set, right? And we can do that, and this also has to be initialized. When we try to adjust the set, we have to initialize it. So we're just gonna make this equal to 0. And what if we have a person pass in a value for rooms, and for some reason we want to double it, for some reason, we can just do field, and we have access to the value that the user passed in, right? So we can just do value, and if we want to do some other stuff too, we could. So if I want to times it by 2, I could do that, and if I want to print that out so you guys can see, for some reason I have double the rooms, and I'm gonna just pass in a string template real quick that holds the house dot rooms. So look, you guys see that, look, I'm passing in green and I'm passing in the room as 5s. I never set the value of 5. I never set the room amounts anywhere else. I know it's gonna be 5, but then when I get here, I'm setting that value that I'm passing in, which is 5, and I'm multiplying it by 2. So what should I expect to see? Some quick maths. If I run this, I should expect to see 10. So I doubled the rooms. So these are the things that you have access to do. Yes, Kotlin handles some things, in the background, but you have access to manipulate the logic if need be. And Kotlin gives you the freedom to do that. So that's the cool thing about Kotlin. You have setters and getters, and we can just change this back into fields, and it should work as it did before. Oh, what is going on? Oh, my bad. See, that's where I messed up. It's data. I make mistakes too. So boom, green and red. So field didn't have a value, so it was empty, but now I know that the data that the user is passing is going to be what I assigned the field, and that field is going to go to whatever that user tried to retrieve. So cool stuff. If you guys ever want to change the logic of the get or set, you can do that just by putting it under the property and assigning and using these variables. So alright, so now that we got some knowledge in our back pocket about OOP, we can start talking about an important concept in OOP, which is inheritance. We're going to start building relationships. Inheritance, just like the name implies, allows us to inherit from a class, a base class, a parent class. This is the class that subclasses will retrieve properties from. So just like in real life, how you have a parent and you have siblings, and sometimes that sibling may get that compliment like, man, you look just like your parent, because there are certain properties that your sibling or even you have that look just like your parent. You're not the same person, but you have properties that you can grab from your parents. Like I said, your nose, your eyes, the way you speak. So the same thing implies in OOP. You may have a parent class, a base class that is similar to the subclasses. Like they're the template, and you have subclasses that branch off from that. So that's the importance of inheritance. When a project gets big and you know that there's going to be classes that are very similar, you might want to have a template that those subclasses can retrieve from. So in our project, we've been using the house pretty much for every example in relation to a class and objects. So what is a house in the grand scheme of things? A house is a building, and there are various different types of buildings, and it's just not a house. It can be an apartment, a skyscraper. And what makes these things different is many things. Like a house can be only one resident, where an apartment can be a list of residents or a list of tenants, and a skyscraper can include a list of corporations. They're still considered tenants, but now you're talking about floors and floors and floors of different types of tenants and buildings and the shape, but they're still a building at the end of the day. Let's look into that. So before, I used to write all these classes underneath main. Let's be proper. Let me make a new class, and we're gonna call this building, and this is where we're gonna make our parent class. Now this is just a regular class, and by default in Kotlin it's final, which means that it doesn't allow for subclasses to inherit from this. Now to make this inheritable, to make this a parent class, we can put a keyword right in front of this class keyword, and this keyword is going to be open. Now we're open for business. Now other classes can inherit from this class because it's open to do so. Alright, so now that we have a open building class, let's start defining some properties that we would want our class or subclasses to retrieve when we build that relationship with the parent class. So we have building as a template, but what does every building have or should have? So if I go into this class, I can start thinking of that. So what does every building have? It should have at least one room. So we can have a property called rooms, and I'm gonna make that a val, and I'm gonna make that an int, and then I'll have a default value of 0, and then I'm gonna have another property called bathrooms, because I don't want them making you guys use the restroom outside. So I'll make that a double, because like I discussed before, a bathroom in a house standpoint can be considered half, or can be considered 0.5 if it just has a toilet. But if it has a shower and a toilet, then it's considered a full bathroom. Maybe in a building that it may just be the toilet considered as one bathrooms, but I want to give the user the chance or the opportunity. If they want to consider half a bathroom, they can do that. So I'll make that a double, and I'll have that holding 0.0. Then I will have color, and I'll make that a var, because we don't want to restrict the user to just one value for color. It could change. We can get a painter and they can change the color to another type. So we'll make that a string, and we'll have that empty. And we can even have methods. But besides that, a building should have an owner, so they handle the responsibilities of the actual building. So let me just create a property at the top called var, because the owner could change with any real estate property. The owner could change if the owner chooses to sell it or if it forecloses. So we'll have that as owner of var, and we'll make that a string, and it's going to be empty for now. And then we can have a method that prints out the owner, just a nice little welcome, like hello, I am the owner. So we'll have a function owner prompt, just so that people can know who's the owner. Open that up, no parameters, because we're just going to retrieve the owner value, and we're going to just do a println. Open that up, hello. We're just going to do something basic. The owner is, and then we're going to have some string templating, and we'll just put owner. Oop, wrong one. It should be $, and boom. Now it's grabbing the owner from the properties, and it's going to print it out if it does have an owner. So you probably think we're done, but that is not the case. See, just like how the class needs an open keyword so that a subclass can retrieve the properties, we still have to make, because by default, a class is final in Kotlin, but the properties also need the open keyword for the subclasses to override the value if need be. So just gotta put open in front of the properties that you want subclasses to be able to change. So you can just do that and change that. So I want all of these to be open, so that if my subclasses want to change it or retrieve it, it is possible. So now everything's open. Everything's open for business. Now let's create a subclass that will be inheriting or building that relationship with the parent class of building. So I know a house is a building, and we've been using it in the previous examples, but we're going to create that class, a specific class just for house. Alright, now to inherit or to make that relationship with the building parent class or base class, all you got to do is put a colon right after the name of the class and put the name of the parent class, which in this case is building. And yes, there isn't a constructor in the building, but we still got to define, a primary constructor. So we can just put an empty constructor, because we don't have any parameters that we're accepting at this time. But it is possible, and we're gonna look at that later. But now we have the opportunity to start overriding properties. So to start getting value, so if you want to use a primary constructor from house to start defining some of the values that we took from the building template or the building base class, parent class, we could. So now all we got to do is use the keyword override. Alright, and now we just need to use the properties that we define in the building, and we can override those values with whatever value that the user passes into the house constructor. So let's do that. So remember, override, and we have 4 properties, so we're gonna have to create an override for each of these properties if need be. Alright, so let's start with owner, and file owner, and we're gonna make that string. And boom, the first mistake already, but it's an intentional mistake. As you guys can see, there's a little swiggly that says var property cannot override a var property. So we're able to see that there's a connection, and the issue is that in building we define the property as a var, right? But in this case we can't just switch from a var to a val. That's going to cause a problem. So we got to change this from a val to a var. But the weird thing, or not the weird thing, it makes sense, but if this was a val, we're able to make this a var, because the only difference between a var and a val is the fact that a val is not mutable, which means we can't change the value, right? But it's not an issue if initially, this is we're not able to change the value, and now we want it to be able to change the value. But before, if it was we were able to change the value and now we wanted to not be able to change the value, that's going to cause a problem. So the original class or the parent class could have a val, and then we can override it as a var. That's possible, because now all we want to do is apply that setter, and that wouldn't be an issue. So just think about that. But now we have to override the other values. So override, and there was rooms, and that was a val, so we can do that, and rooms, and that is going to be an int. And just so that it's cleaner, let's put it each on one line. Oops. And okay. Override. And then we'll make that a val for bathrooms. And then we do one more final override for var, and this is going to be color string. Alright, so now we override all the values that the user passes in, and this is taking reference to the building parent class, and as you guys can see, they're all grown up now, meaning that we overrided the values based on what the user passes in the house class, and now we have access to it. Beautiful. But look, we also define a method in the building parent class, so we can also override that as well because it's open. So if you guys can see, it gives me the option to override the owner prompt, which I want to write it out by hand because it's better to do that so you guys can learn it. Oh, it already we already built it. IntelliJ's too smart. But look, we could define our own prompt here. We just do println, and we can do welcome from, and then put the name of the owner that we passed in through the constructor, if I can spell welcome properly. And now if I go into the main, I can literally just make an instance of house, pass in the owner, which I'm going to put as Geo. It's going to be a nice little 5 bath or 5 room, 5 or 6.5 bathroom. It's going to be a nice little I'll make it green or emeralds, like some Wizard of Oz type thing. But if I run this after I do the house dot owner prompt, you guys will see the prompt I just created by overriding welcome from Geo. So if I go into building, originally you see the owner is owner, but since I overrided the property and defined my own print statement inside, it pretty much erased everything from here and just defined what I put, which is awesome. But what if we're okay with the original value? So if we're okay with the original prompt, we could just get the instance of the original base class version of it by using the keyword super and then using a dot on a prompt. So now we have the original return value of the method, of the original method. So now we should expect it to return the owner is Geo. So if I go back to the main and I run that, boom, the owner is Geo. And that's just the magic of building the relationship with parent and subclasses using inheritance. Now if we want to use the template, we could. We have a template, and now we can inherit as many times as we want within other classes, and now we can even use the original properties or the original method value, or we can create our own by overriding it. We overrided the properties ourselves, and we overrided the method that we created. So Either or, we can choose. So that's the cool thing about inheritance. Alright, so just as promised, I created a constructor for the building parent class. And I have the user passing in the market price. And every building has a market price, whether it's low or whether it's high, it still has a price for someone to buy and live in or use. So in this case, I have a market price being taken in from the constructor, and I have a init that's printing out the current value when the person passes in the market price. And then I have the regular properties and method that was originally a part of the building class. So now that you guys seen this, I also created the apartments class. All right, and this is going to be overriding all the properties that we originally had in the building class, but also taking two additional properties that is specific to the apartment. So we have a price that is double, and we're not overriding it because it's only specific to the apartment class. And we have a tenant's map. This is going to be holding an int to specify whether a person lives, what room the person lives in. You know, because in an apartment, everybody has a room number that specifies, you know, the current location that the tenant is living in. So it can be room 101 for the first floor or 205 for the second floor, things like that. And then we're passing in the price that is being passed in through the apartment constructor. Because we're inheriting from the building, we still have to pass in the value that the building is expecting. So like I said, we have a primary constructor that is expecting a market price. So the price that we're expecting from the apartment, we can pass that to the building class primary constructor. And then once the building class gets that, it will print this right away with the price that was passed in through the primary constructor. Then the tenants, I created a init that will initialize this tenant property that I created specifically for the apartment class, and it will equal the tenants that the user passed in. And then from there, I created a print tenant that's specific to only the apartment class, and this will print out a tenant based on the ID. So I have a tutorial that I went over maps and how to create a map and arrays and stuff like that. But to get the instance of a specific tenant, I'm passing the ID, which is going to be the room number. I could have used room number, but in this case I'm using ID. And if it's not equal to null, that means someone's living there. So I just print out the current tenant. And because you don't want to just print out all your tenants, like you should only, you know, print out a specific tenant if the person knows the room number. And if that doesn't exist, then that means there's no current tenant living there. So I feel like this is a kind of realistic scenario for apartment, and you can add way more stuff. That'll be a little project for you guys, but this is my apartment class, and this is what it can do. And I'm gonna have the code on my website, which is techwithgeo.com, and I'll leave the link in the description. But now if I go to the main, I'll create an instance of apartments. The owner is going to be Geo Corp. The apartment's going to have 30 rooms, 35.5 bathrooms. You know, there's one bathroom in the office that, you know, doesn't have a shower. So, and then the color is going to be yellow for the apartment complex. The current price for the apartment is $200,000, and we're going to create one map. Like I said, I went over how to, maps and, arrays and the basics of Kotlin in another video. I have a whole playlist actually, if you guys want to look into that. But I'm creating a map with just one tenant. This is a fresh apartment, and this tenant has a room number of 1, and his name is Luke Skywalker. And then after that, I am printing out a tenant. So I'm passing in the ID. And if a person lives there, then it'll print out, who lives there. So in this case, it'll probably be Luke Skywalker because we only have one tenant. So if I run this, boom, the current market price is 200,000.5, which we specified here, and that's being printed out from the building class from the init, the current market price, as we pass in the market price from within the apartment class. The price that we passed in is being passed in through the primary constructor of building class, which we're inheriting from. And the second print statement is coming from the print tenant, which is current tenant is Luke Skywalker. So if we go back to apartments, it is doing this logic, and it's seeing that there is a value within the map and it's printing out the current tenant living under that ID or that room number. Now, if I go back to main and I put 2, and then I run this, the market price is still going to be 200,000 because that's what we're passing in. But it's saying that there is no current tenant living there, because I mean, if you check the map that we're passing in, I mean, there is no 2. So if we try to see if someone's living at 2, then there's nobody living at 2. So this is how we can use, inheritance. It's pretty awesome. We can have this template, but additionally we can have our own properties that's specific to the class that we made, such as tenants and price, and even price can be added to the building, because like I said, price is every building has a price, so whether someone is choosing to sell it or not. So you guys can look at this on my website, or you guys can write it out and rewatch this to see how you can add your own properties and logic to make this more robust. So hope you guys enjoy the video. Alright, so let's start talking about visibility in Kotlin. So before, we were just making an instance of our apartment. We're passing in values into the constructor, and it will assign those values to the properties that we define in the class. Sounds correct. But let's start thinking more realistic, in a realistic scenario type of thing, in real world application. So apartment has all these properties, but when we use dot notation with apartment, you're able to see all the things that are currently, or all the properties and methods that are currently inside of apartment. In a real life scenario, that's probably not a good thing. You don't want things to be so visible, right? Because I can just go in, I can pick apartment.tenants, I can make this equal to map of, and now I have no idea who are my tenants, because now my tenants are going to become an empty map. Now all my tenants, I got to go door by door and figure out who's who, and that's not a good problem to have. So one way to fix that, as I erase this, is to change the visibility of our properties. We can go into apartments, and there are 4 modifiers, visibility modifiers in Kotlin. There's public, which by default, if you don't specify a modifier, then everything is public, which is visible to everything from everywhere. And then there's private, which means that it's only visible where it's declared. So as you guys can see, that there's this tenant's property declared in the apartment class, and right now by default it's public. But if I set this to private, now it's only can be seen, or it can be changed from within this place that is declared, which is the apartments class. But if I go into my main and I try to do the same thing as I did before and use the dot notation to try to see properties to change, tenants is not available. I mean, I can still print out tenant. I mean, I'm still passing in the value for tenant, which is this map of Luke Skywalker. But if I run this, right, and I have no access to tenants, but I can still see what's going on in the background based on the information that I passed in, or the data that I passed in from the constructor. But I just can't change it after, because I can't see it after. I don't want it to be visible, because of it can be changed for malicious intent or even by accident. So then that is private. You only want to be seen from where it was declared. But then you have another thing. See, if I make one of these private, and first of all, first rule, you can't make an open property private, because then the subclasses won't be able to see it. So that kind of defeats the point of making it open, because it will only be seen from the declared class. So that means even if I'm inheriting from building, if I'm trying to make this private, it won't see it. So Kotlin just telling you, yeah, no, that's not a good idea, it's incompatible. But there is another modifier called protected, which means that it can only be seen from within the class that it was declared, as well as subclasses. So it's not blocking it from apartment, which is a subclass of building. But now if I go and try to do the dot notation again, and I made owner protected, so if I try to get owner, it's not there. It's not it's not letting me. I don't have access. It's protected. So visibility. All right, you got to think about the different scenarios of how you want things to be seen in your application, and different scenarios on, what do you want users to be able to touch. And in this case, I might want to create my own function that checks if that person is actually valid to change the ownership to somebody else. So you just got to think about that. All right, so the last visibility modifier is internal, which means that it's visible within the module. And we talked about modules a little bit in my first Kotlin tutorial. Module is just in Kotlin is just a set of Kotlin files compiled together. So that can be, Maven projects, Gradle sets, IntelliJ modules. Those are all modules, and they're compiled together. So really, on a realistic setting, unless you're using modules or playing around with modules, you won't really use this modifier too much. But I just wanted to provide you guys context on what it actually does. And if you do, then internal. If you only want it to be seen within the module, then internal will be used. So okay, we have public, which is by default, everything is public in Kotlin, and it's visible from everywhere. Then we have private, which can only be viewed from within the class. And then we have protected, which is viewed from within the class or where it's declared, and the subclasses. So if I make something protected in building, apartment is inheriting from building, so I can see it from here, but I can't retrieve it from anywhere else, or I can't set it or retrieve it from anywhere else. And then there's internal, which is visible within the modules. So you can just literally put let me see, instead of private I can put internal. You just put the internal keyword, and it's visible from only within the module. So yeah, I mean, it's saying right now that it's recommending private, but I just wanted to show you guys how internal looks like. So thank you guys for watching. Alright, so to begin the Kotlin Object Oriented Programming journey, I talked about classes, which is used as the blueprint for the creation of objects. But we will now talk about another type of class, which is the abstract class. So first, an abstract class cannot be used to create an instance of an object. So like how we had before with this apartment class, which holds different properties and methods, we can't create an instance of it by passing in values in the constructor and making this variable called apartment to hold the instance of that object. It's not possible to abstract class. So what's so special about an abstract class? Well, let's create one first, and then we'll talk about it step by step. So first, we'll just make another Kotlin class. We'll call it building details, because I want to define some building details about the one that we created. And then now, to make this class abstract, all you got to do is put the keyword abstract in front of it. So now we have an abstract class. So now we can start defining some abstract class properties and methods. Now, by default, any property in an abstract class is non-abstract. So to override it, we either have to declare it as open, or we can create it as abstract, which by default abstract properties and methods are open. So let's create an abstract property. So we're gonna call this abstract, and we're gonna make this a file with the floor amount of the building, because we want to know how many floors the building has. And we'll make this an int. So the first thing about an abstract property or method is that they cannot be implemented. I can't make this equal to 0 to give it a default value. That's not possible because it's abstract. Only the subclass that's inheriting from building details can implement it. So if something is, or if a subclass is inheriting from building details, it has to implement the abstract properties and methods. You cannot go without, implementing them. So let's create another abstract, let's use the abstract keyword again, but we're going to use it to make a method. So we're going to make this one, and then we're going to make building prompts, and this is going to be used to welcome guests into the building. But again, this can't be implemented because it is abstract. All right, but an abstract class can contain abstract and non-abstract properties. So we could have, let me see, what's a good, let's do var window type, and we're gonna make this a string, and maybe it's impact, and by default we'll just make this empty. This is possible just because we're in an abstract class. Like I said before, you know, all properties inside the class properties by default are non-abstract. So to override it, or if you want to override it, we have to place it as open. But because it's non-abstract, it's not using the abstract keyword, we could implement it. So for now, I'm just making it as an empty string, and whoever inherits from this building details class can implement it from, or can override it from the original empty string. So an abstract class is perfect if you know you're going to have subclasses that will need to define certain properties and methods for sure, because by default you have to implement the abstract properties and methods. And let's make sure that, you know, I'm telling the truth. Let's go into building, right? And to inherit from an abstract class, you just do like we did before with an open, you know, with a parent class. You just do in the colon, and then you put the name of the file you're trying to inherit from, or the class that you're trying to inherit from. So in this case, we want to inherit from this abstract class building details. Now you're gonna see some squiggly lines. So first, let's put in the primary constructor. But you're gonna see some squiggly lines up here from IntelliJ saying that class building is not abstract and does not implement abstract base class member floor mounts, and also you know, because building details have this building prompt, that's also abstract. We need to implement that as well. Now it's saying it's not abstract as well. Now if we made this abstract, we wouldn't have to implement it because it's also abstract. So we can also have abstract properties inside of it and non-abstract properties. So that's why these still work. And apartments still work because it's, you know, it's still inheriting from building. So everything will still work. But now that it's not, now that apartment is not abstract, it will have to implement the things that, you know, building is inheriting from, which is everything from building details. So it'll pretty much start a chain. So let's remove this as abstract. Let's make this open, and let's just implement what they want us to implement. So let's override the floor mount, and we're not going to use the getters and setters. We're just going to make this equal to 0 as well. Whoops. And we're going to override the building prompt as well, and we're just going to print out welcome to, and then we're just going to do welcome to my building. So boom, now you know for sure, and this error goes away, that if you want to have a class that holds properties and methods that, you know, whoever inherits from it will for sure implement those properties and methods, or have to implement those properties and methods, an abstract class is perfect for that because it creates a dependency that can't be ignored. But the thing is, a subclass can only have one abstract class. So we can't define multiple abstract classes and use multiple of, and just put a comma and just use another one. It can only have one. So make sure whatever you need is within the abstract class. But like I showed before, there could be a chaining type of thing. So if necessary, that can be done with multiple abstract classes. Alright, so we got the value from building details, and we overridden it and implemented it just like the abstract class wanted, or the abstract property and method wanted. But what if we want to use it in the apartment class? Well, we still got to go through the same process. So to get the floor amount, we could just override it again. So we're gonna do override val, and then let me just put a comma. Override val floor amount, right? And then we got to go back into our, you know, instance of apartment and, you know, add that property or that parameter. But then let's make that prompt for the building as well. So let's override, right? And then let's put the function of building, and we're just going to use the instance that building prompt originally have, which is welcome to my building. And if you want to add your own name to apartments, the apartment primary constructor, and then use that name, like welcome to my beautiful estates, or whatever the name of your apartment is. Apartments have names. Then you can do that as well. But in this case, I'm just going to use the version that I created in my parent class. And now it should be good. Now I just got to go back to my main, and I believe I put it right here. So I just got to put how many floors does this apartment have. I'm going to define it as 3, and look, floor amount is 3, price is 200,000. You guys could do this floor amount equal if you want to make sure, as if your constructor is getting big like this, you can do that as well, just to make sure you're putting in the right values. But luckily IntelliJ is smart enough so I can see the name right next to it. But if you want to make it clean, you could put the name of the parameter. Up to you. But let's run this. Let's do apartment dot building prompt. Run this. And then boom, welcome to my building. It takes because we're using super, like we learned before, or let me find the file. Because we're using super, we're just taking the version of the parent class, and just to show that I'm getting the proper floor amount, let me just print that out as well. Print ln, and then apartment dot floor amount, and we can make this private if we wanted to, or protected, whatever you guys want. But just for show, you can see that I'm passing in 3 as floor amount, and I'm able to get that value. Now if you don't want to be able to retrieve floor amount like we just did, we can just go to building details, and we can just make this floor amounts protected. So now only the subclasses and the place that is created can see floor amount. So if I go back to the main, now it's showing the red squiggly. Can I access floor amount? It is protected. And you shouldn't make it private because it's open, and other classes gotta override it. So private is not an option. So protected is perfect for this case when you're gonna have subclasses that inherit from building details and building. So this is perfect. But now we can't do this anymore. But building prompt is still an option, and we're still able to pass in the value to floor amount. So this is abstract classes. This is how you can use them. Remember, you can only inherit from one abstract class, but you can create this chaining effect. So if possible, like I showed before, you can have this abstract class, you can make building abstract, and then you can have class inherit from building, and then you have to implement the 2 abstract properties, or whatever abstract properties that you define in apartments. And I can keep going and going and going and going until you have your class that you want to inherit all those properties that you created. So you just got to figure out, do you need a abstract class to hold properties and methods that you want for sure to be implemented? So think about it and play with it. Alright, so in the last video I went over abstract classes, but now we'll start talking about interfaces and how to create one. So what is an interface? An interface is a type where we can implement abstract methods, properties, and method implementations. So it sounds pretty much very similar to an abstract class. By default, everything defined in an interface is abstract, unlike the abstract class where everything is by default non-abstract. So let's create one. Let's create a maintenance interface. This is so that we can check the current status of our building in regards to maintenance for either a tenant, or maybe you just have a regular house and you want to check the status of a specific problem that you're having. So let's create new Kotlin class /file, and then we'll just do building maintenance. I hope I spelled that properly. And then we're going to choose interface, and boom, now we have an interface. It's literally just the interface keyword and the name of the interface. So now let's start defining some properties and functions. So the first one I'm gonna have is gonna be called file, and then I'm going to put maintenance status. So it can either be pending, or it can be completed. So that's a string. But like I said, by default, anything created in an interface is abstract. So if I try to assign it as an empty string, it's not possible, because by default, it's not allowed in interfaces because it's abstract. So whoever the subclass that inherits from this interface will be able to implement it by overriding it. And because it's abstract, it's open, so you'll be able to override it. So before, I talked about how interfaces and abstract classes are very similar, but they're not exactly the same. Like I said, properties in the interface by default is abstract, and by default, abstract keywords are open by default. A class can extend many interfaces, but like I discussed in the previous video, an abstract class can only be inherited once. But we can create a training effect if needed. An interface does not store state, so as you guys saw that we tried to give it a value, but because it's abstract, it doesn't allow us to do it. But if you're going to return the same value all the time, if you really want to return a specific value, you could use the getter that we learned in the getter and setter video. So you could just do this, or open a string. You could do this and set the getter to an empty string, but for the most part, you'll just be overriding it. But if you really want to have a value, then you use the getter. Because an interface is not a class, it's a type, it does not have a primary constructor. So we can't just put parentheses over here and accept the value, because it's not going to allow for that. Interfaces do not have a constructor. Alright, so now we'll start defining some methods within this interface. So let's create a method that will print out the status of maintenance. So let's put prompt status, and now we created an abstract method within this interface, but we are allowed to have normal methods. So we just got to open it up, provided a body, and now this is just a normal method. It's not abstract, and it doesn't need to be overridden. So let's just create a prompt, and we're going to print out the status. So we're just going to put status, and then use some string templating. And I'm pretty sure I have a misspelling somewhere. Maintenance. So I'm just gonna copy this. Maintenance status. Alright, cool. So now when the maintenance status is overwritten, if we try to use prompt status, then it'll print out the current status. But because it is not open, we cannot override it. So if we do want to override it, we could put open. But if you don't, and you just want to print out the prompt status, then you can just do it based on the maintenance status that you override, the value that you override maintenance status with. So now let's see it in action. Let's inherit this. So we're going to go all the way back to building. We're going to put a comma after this. We're going to put building maintenance. It's going to show the squiggly like before, where it's saying that you have some abstract property that needs to be implemented. So we can just override it. And in this building, I am going to place it right under here. Open, or actually override maintenance status. And we can use the getter, but we're not. We're just going to allow for it to be overwritten. So it's going to say that you need to initialize it. We're going to make this equal to an empty string. But now this is accessible in apartment. So if we want to go into apartment, because it's inheriting from building. So this is the effect. So we got this interface, which is put into building because we want to know the maintenance of this building, the current status. So we inherit from this interface. And now you see that everything is lit up because we inherited building maintenance within building. So now all those properties are available within here, but because apartment is inheriting from building, apartment has access to those properties as well. So if we want to pass that in, we can override maintenance status, put that, and then go back into the main, and then we can put it right before here. So I'll just put pending and put a comma. So now if I do apartment dot building prompt, oh, not building prompt, dot, let me see, maintenance, no, the prompt status, there it is. And I'm just gonna print comment out these print statements. If I run this, I should expect to see status, and then it should have the status that we provided, which is pending. So on a bigger scale, we'll probably make a map, which would have another map within this with each tenant, and each tenant will have their own version of maintenance status, because everybody in the building should have their own status for an apartment, because every apartment room has different problems. So in a bigger scale, you probably take the maintenance status that we're taking from the building maintenance interface and provide it inside of this map. And we could probably make another object called tenants and pass that in inside of a map. So there's a lot of things that you can do, but on a simpler scale, that's pretty much how to use an interface, how to create properties. Some can be either abstract, or you can have a method that is non-abstract. That can be overwritten, but it can have a default value that we use, which we're using now, which is taking the maintenance status that we override, and the value that's being passed from apartments is being used to print out the status here. So there's a lot of ways you can play around with interfaces, but yeah, and you're not just restricted to just using one interface. You can use many. So now let's create another interface that will hold information, properties, methods regarding building staff. So we can know who works for our apartment, and what's their ID and what's their name. So we'll create another interface, and Kotlin class/file. We're gonna call this building staff. Make it as an interface. Now let's start defining some properties. So we're gonna make this a map. So let's do val, and then we're gonna do staff, or building staff. We're gonna make this a map of string, or actually we'll just do ID and the name. So we'll do int and string. If you guys want to make it more difficult, you could create another object called employee and have that as the second option instead of string, and then you can dive in deeper on the employee. So you can create properties for the employee, like name, description on what they do, their role. So that's an option, but I'm just gonna keep it simple and have an int for the ID and string for the name, and yeah, that'll be it. And that is our first abstract property, because by default, like I said before, all properties by default in an interface is abstract. So now I'll just create another, or I create a method that will tell me how many staff members I have. So we'll just create a function called amount of staff, capital S, camel case, and then open up parentheses and open up the body, because we are able to have abstract and non-abstract methods. So in this case, I want to create a method with a implementation. So I'll just create a prompt that will take the size of my building staff and return it. So we'll just do amount of staff is, and then do some string templating, open that up, and then building staff dot size. And now whenever we override this building staff with some members of our staff, or if there's no staff, then when we use the amount of staff, when we print this out, it'll just print out the size of the staff. And then you can create another method, and that'll be homework. Create another method that iterates to the staff, or you can do like I did before, get the index of the staff member and then use it to print out the staff. Or if there's no staff, then it'll print out there is no staff by the ID. And that's some little homework for you. But all right, then we'll go back into building, and now that we have another interface, all we got to do is put in a comma and then put the name of the interface that we just created, which is building staff. All right, and you are able to inherit multiple interfaces, but the squiggly line is saying, okay, you have some abstract properties or an abstract method that needs to be implemented. So we'll just create an override here for building staff, right, and then we'll just make this an empty map, because right now we don't want it implemented here. We want to implement it in our next subclass, so we'll just have it empty here. And like I said before, you can inherit multiple interfaces, but you can only inherit one abstract class. So now let's go to our final subclass that's inheriting building, and here I will allow for the creation of employees. And right here I want to create another private var, and I'm going to call this employees, or staff. Let's call it staff. And I'm gonna make this a map of, and then I'm gonna make this an int and a string. All right, and then this dot, but I gotta make staff so I can pass it in, but make that equal to staff, and we should be good to go. All I gotta do is add it. Let me make it right next to this tenants, so I'll just call it staff, and I'll make this a map, and it'll be the same thing, int and a string. Now if I go back into our main, I now have to implement that map, and I'm just gonna make one person, so 1 2, and I'm gonna name the staff member Bobby Bossman. I'm really bad at making fig names, but then we have access to, even though we didn't override, or we don't have the value here, we still have access to the interface, because we're inheriting from building. And if you go back to building, that's inheriting from building staff, and if you go back to building staff, I still have this amount of staff. I have access to this. So if I go to apartment dot, and then I should be able to see amount of staff, and go down, select that. Now if I run this, I'll keep this so you guys just still see the prompt status. So now I should see the current value is 200,000, which is the first print from our initial tutorial. But then there's the status, which is pending, which is the second print, and then there's the amount of staff, which is 0. Whoa, wait a minute. We made a mistake, and I'm gonna keep this in because I want to know why exactly is this not working. So we have staff, and we're passing that to staff right here. We're making this staff equal to staff, and okay, we didn't override. We did not override to actually assign it staff. So we can do that here. Let's override, and it'll just be building staff. So instead of it being staff, it'll be building staff. And now we should be good to go. Now if we run this from the main, it should say 1. So that's a very simple mistake to make. You do have to override the values that you're inheriting from, and because there's no implementation yet, so that was the mistake to make. But now you guys know you can have multiple interfaces, and pretty much created that chaining effect. We have building, which inherits from building interface, so we have our properties and our method. Go back to building, you can override it, put some default values in here, but then if I go back to apartment, I can override that again and place in the value that I want to use. and then I can assign that to my internal property, which is staff. So, but that's just going to be equal to the building staff. So, thank you guys for watching. Alright, so let's start talking about nested classes. This class is getting pretty big, so I'm gonna make another class called skyscraper. Or actually no, we're gonna do office building. We're gonna make an office building, for like your dentist and stuff. So let's do new class, and then we're gonna name this office building, and then we're going to inherit from building. Open up that. Now it's expecting market price, so we'll just open up a constructor here so we can pass in what they expect. Honestly, I'm just gonna go to apartments and take all the overridden values. So I'm gonna just take these four, and then open this up, paste that in, and then we'll have a market price. Market price, and then we're gonna make this a double, right? So now the person can pass in market price, and that market price will be passed into building because they're expecting a market price for the building. And then I also want to make a map for the list of corporations that are in this, or a map of corporations that are in this building, and it's gonna have the room number that the office number that that corporation is using. So we're gonna do corporations, and then we're gonna do open that up, map, open that up, make that int, and make that a string. So now in here we're gonna make a private variable, and we're gonna make that equal to corporations, and that is going to be a map and an int and a string, and then we're just gonna go into this init block so that we can initialize corporations. So it's gonna be this star corporations is equal to corporations, so that should take that away. Alright, now we can start talking a little bit about the nested class. To create a nested class, we simply just need to place a class within a class. As the name implies, it's a nested class. So we have this office building class, and now we want to create another class called storage, which will be a class specific to storing items based on the corporations that's in the office building. So let's just put that class keyword, use storage, and then open up some brackets or curly braces, and then now we can start defining some properties within this nested class. Now the interesting thing about nested class is, yes, it's within another class, but we do not have access to properties within the enclosing class. So just because we have this class storage inside of office building, we do not have access to corporations or any of the properties that we define in this enclosing class of office building. So storage is its own space. We can create our own property specifically for storage. So let's call this new property. I'm gonna make this var storage items, and it's going to be we're just gonna make it a map. Well, actually no, I'll pass the value through the storage primary constructor, which we could do. It's a class within a class, but it still does have its own primary constructor. And we're gonna make this val storage items, and then we're gonna make this a map. I still want to make it a string, or an int and a string, because we're gonna use the corporation's room number, and we're gonna use string to pass in whatever item it is. You could make this a list or another map, a list or map if you want to, but I'm just gonna make it a string so I can pass in one value. And then I just use init, and I actually do need to make another var storage item map, and I am going to make this a map, and then I'm gonna make this private actually because I don't want to give people access to do it. You can make another function that puts values into a map if need be, but that'd have to be a mutable map. And then make this a string, and then this dot storage item map equals storage items. Now you're probably wondering, okay, how do I get access of this class within the class? Alright, so let's go back to our main, and it's not just as easy as just implementing this office building, which is holding our nested class, and just doing office building dots. It's not even going to be seen. I could put S and IntelliJ or Kotlin doesn't see it, but what I need to do is get the class that's enclosing it. So in this case it's office building, then use dot notation to see what's within that class. And now I can get storage, and now I can use that primary constructor to pass in values that I defined. So in this case I created a map parameter for the storage items, and now I can do or create a map of different corporations. So now I'm just going to do 101, and that's going to be to Starbucks. Boom. So now we have office building, which is referencing back to the storage nested class that we created, and through this nested class I am passing a map, and with that map I am storing the storage items to the private map that I created within my init block. So now I want to create a function that will allow us to print out what the corporation is storing. So we'll do a fun and then print storage item. So then we'll just go to pass in a index or a room number, and that's going to be an int. And with that int, we'll check if the map has, let me fix this misspelling. We'll check if that room number has anything in the storage. So we'll just print out, or we'll do an if statement first that will check if storage item map at the room number is not equal to null, to check if it actually does have a value. And if it's not equal to null, then I can print out the storage item map at that room number. Else, then print out no storage item. Now if I go back to the main and I do and I'm gonna make, because this is an instance of storage right here, so I can put this as a variable that holds that instance of storage. I'm gonna make that equal to that, and then I can do storage dot print storage items, and then I can pass in 101 because that's within the map right here. And let me just comment these out. Now if I run this, obviously it's going to print out the current value of each instance that I create of building, because I have a init in building that print out the market price. But besides that, you are able to see that I have a map that's printing out Starbucks or whatever item that I'm storing in this storage. So it's its own space. Storage is its own space. It's nested, but I can still have an instance of it, and I can pass it to this. I can have the storage variable that holds an instance of storage just by using the enclosing class, then using dot notation to retrieve that instance or that class of storage, and then create an instance of it by passing in the necessary parameters if you are using any values in the primary constructor, or you can use an empty primary constructor. And just because it's enclosed in this parent class does not mean that you can't use it like a regular class by giving it a parameter and using that value in a constructor and all that. So this is an example of a nested class. Now you're probably wondering, what if we do want to use the properties that the enclosing class has to offer? So what if we do want access to this corporation property from within this nested class of storage? Well, there is another keyword that we can use called inner, and all we gotta do is plug that from in front of the nested class declaration, and now we have access to corporations. So now to use that, all we gotta do is, so first, now that I have access to the property from within the enclosing class, I want to check if corporations room number and storage item map room number both is not null, so that I can print out the name of the corporation and that I can print out the item that that corporation has. So I'll just add in an and, which I believe that's 2 ampersands. I think that's what they're called, ampersand. And then we'll do corporations, and as you guys can see, I can see it now. Before, when I took inner, when I didn't have inner, corporations was not showing up because I didn't have access to it. But with the inner keyword, I do, and now it's not going to get mad at me. And then I can use the room number, and as long as that is not equal to null, right, we should be good to go. So I'll print out, actually now I just make it in 1. So I'll print out the corporations and use that room number to get the string value, and then I'll just actually I'll plug this into a string so I can put in a colon to make it a little bit cleaner, and then I'll use a $sign string template and open that up, put a little colon in between. Oh, I missed the $. Then plug that in there, and now we should be good to go. Alright, so we got to make sure that the map is holding a specific room number for that corporation, and that corporation has that item within the storage, so that they're both not null. So now if I go back into the application but now we got to actually pass in a constructor, and honestly we already have an instance right here, so all we got to do, made a mistake there, open that back up. All we got to do is, let me comment this out, and now I can just take this instance of office building, and now I have access to storage, and I can just pass in this map right here. Actually, I'm not gonna pass in the exact map. I'm gonna pass in the storage value, or the storage items, and we're gonna use that same room number, and we're just gonna have some coffee inside storage. Now if I want to print out the storage, I can now use office building and then use .print storage item. Pretty neat. Now if I run this for 101, now it's saying Starbucks, I got some coffee, because now I'm passing in first the corporations, the room number at 101 is Starbucks, and now I have an item within the storage for room number 101 to hold some coffee. That's a plane flies by my house. So now if I go back into the office building, I have access to corporations from within this inner class. I am passing that storage items to hold within this private storage item map, and then I'm just checking if storage item and corporation is not null for that room number, and then if it's not null for both of them, then that means they're correct, and I can print it out. Obviously you can make that if statement we can make it more strict, but we're just gonna keep it simple here. So yeah, that's an inner class. So if you guys do want properties or access to the properties from your enclosing class, you can do that. Thanks for watching. Now it's time to start talking about another type of class, and this class is called the data class. If you have any experience with Java Object Oriented Programming, you probably know about POJOs, which is an acronym for plain old Java objects. It's a class to use to hold data. So now Kotlin implemented a thing called data class, which will help us create a class to hold data. The awesome thing about data classes is that the compiler automatically generates utility functions for the class. This includes equals, hash code, toString, component n, and copy. And we'll go through each one of these utility functions one by one so we can see them in action. To create a data class, all we got to do is go to source, new, and then Kotlin class, and then we'll just make one for employee. And then I'm gonna create a data class. So I go down and select data class, and boom, now we have a data class. The only difference between the declaration of a data class and a class so far is the keyword data in front of class. But there are some rules to create a data class. First, you have to use at least one parameter in the primary constructor. So right now it's showing a red squiggly line because it wants at least one primary constructor parameter. Parameters passed in the primary constructor has to be marked by val or var. So we'll just make a val called name, and that's going to be a string, and that will meet that criteria. Last thing, data classes cannot be abstract, open, sealed, or inner. So if you want any of those type of declarations, that can't be done with data class. Like I said, data class is used to hold data. So if you want it to be abstract where people can inherit from it, that's not what a data class is used for. So it can't be open as well. Things can't inherit from it. And we're going to talk about sealed classes later, but it can't be a sealed class, and it cannot contain, or it cannot be an inner class. So now we have a data class that takes in the name, which is going to be a string. Now we'll see some of the utility functions that a data class comes with on compilation. So let's go back to our main and let's comment all of this out and start from right at the bottom. And we just created an employee data class, so we'll create an instance of employee equals employee. Oops. All right, cool. And now it's expecting the name in the constructor, in the primary constructor. So we'll just use Giovanni. So now we'll start using the utility functions that a data class comes with on compilation. The first utility function we're going to use is the toString. The toString returns the string form of the data class. So currently we just have one parameter that we're passing into the data class, and it's storing that as name, and that value is Giovanni. So let's see this in string form. If we do a println and we do employee, which is holding the instance of employee with my name, and do toString and run that, we should see the string version of my employee using my name. So it's gonna be employee and the name is equal to Giovanni. So that's pretty cool. If you have a instance of an object and you want to see what's under the hood in a very nice to see format, the toString would work. So that's one utility function that comes with a data class by default. And let me just go into, I believe it's in building, and take this println out. Alright, so the next utility function that a data class comes with is the .copy, which, just as the name implies, the copy function just creates a copy of the object that you're trying to create a copy of. So let's see this as an airplane passes by my house. Val employee2, which is going to be the second instance of an employee, and is going to be equal to employee dot copy. Now we're creating a copy of employee, but we got to pass in the parameters for the employee. So since there's only one parameter for employee at this moment, which is just a name, we'll just pass in a new name, which is going to be Jim, which is pretty cool. Now we can create copies of objects without having to create a whole new instance of it. Like now we can just take that instance of employee and just use a dot copy. Pretty convenient. And it's pretty much saying right now with swigglies that we're not using the name arguments, so we can just use name and equal, and that should go away. And now we can just do println and do employee 2.toString just to see how it looks under the hood in a very nice format. And then boom, employee, the first one's gonna be Giovanni because it's this one, and the second one's gonna be employee name equal to Jim, which is this one. So now we have a copy but with a different value. Awesome. Another utility function that we can use is the hash code function, which returns the hash value of the object. So if two objects have the same hash value, they are equal. So let's see what the hash value for employee 1 is, and we'll just print that right after. So we're gonna make a nice little prompt, hash value or hash code of employee 1, and we'll just do string templating, and we'll take the instance of employee and do hash code, and boom. And then we're just gonna copy this, put that right under employee 2, change the prompt just a little bit, and then we're gonna do employee 2.hashcode so we can get the instance of this hash code. Now if we run this, we will see, boom, employee 1 has this long hash code and employee 2 has this hash code. So they're two different hash codes, so that means they're not the same object. And there's an easy way to check if an object is equal. So that takes us to our next utility function, which is the equals function, and this takes in an object to compare with another object to see if they have the same hash value. If they do have the same hash value, then it returns true. If not, then it returns false. So we can just make another println. There's a lot of prints going on, but it's just to see, to output something so you guys can see. So we'll take the instance of employee, then use dot notation to see the functions or the methods that the data class provides, and that is the equals. And then we'll pass in the object that we're trying to compare it to, which is going to be employee 2. And what is this rest wiggly? And we could use the equal to compare as well, but we're going to do the dot equals, and we're going to run this, and then boom, it's false, because we can see here that this hash code and this hash code is different, so they're not equal to each other, so it returns false. When is it going to be true? When is dot equals ever going to return true? And like I said, it has to be equal, or it has to be the same hash code. So when is an instance where an object can be the same? Let's see this in action. So let's create another instance of employee, and let's do employee 3 because this is going to be the third employee. Probably should make a more specific name, but employee 3, and we're going to make this equal to the copy of employee 1, but we're not going to pass in any values. We're not going to pass in a new name because that would change the object. We're going to make it an exact copy. Now we will pass employee 3, which is a copy of employee, and we're going to run this, and as you will see, it is now true. So this is an instance, right? Maybe by accident you created a copy and it's the same object. This is an example of the same object being checked to see if it is the same object, and in this case it is true. There's an age limit to whether a person can be an employee or not, so that would have to be put onto the application regardless. Alright, and that's going to be an int. Let's go back to the main and let's use component n. So by default, component n is generated for each parameter, like I said, for destructuring. So let's do that. Let's extract the parameters that we have for an instance of an object. We're going to do name, age, and that's going to equal to employee. And this is probably looking ridiculous, but let's do this so you can print it out and see what's exactly happening. If I can spell println right. Let's do employee name is name and age is age. And we'll run this and be amazed. So look, an employee name is Giovanni and age is 20. Like how, right? So with the component n that is generated for each parameter, we have the ability to destructure, which means we can extract them. And with this notation right here, we can extract each parameter. If we put in parentheses and pass in the name of the parameters, we are now extracting those values from this instance of employee and assigning it to these variables. So now name and age is the name and age in this employee. So now we can just use that n-word that we like because we just extracted because of the component n generated for each parameter. So data classes come with so many utility functions that will be necessary for the stored state that we have for each instance of a data class. So that's one thing you got to think about. If you want a class to store the states or that's going to hold data, a data class is perfect. Now if you want something that needs to be inherited from, or you want a sealed class or an inner class, then a data class is not for you. But if you know you're gonna store some data and you're gonna need some of these utility functions, then a data class is perfect for you. All right, so so the last class we'll be talking about in this series is called the sealed class. A sealed class allows for more control during inheritance. It forces a single type from a limited set known at compile time, which is called restricted hierarchies. Sealed classes restrict the ability to create subclasses. So let's create a sealed class. Let's do new and then Kotlin class filed, and we'll call this booking. And then we'll go down and select sealed class, and boom, we now have a sealed class. Now, a sealed class cannot be instantiated and it's abstract by itself. Constructors in a sealed class is private by default. It cannot be open, which I mean can be overridden, or not overridden, but there is no properties to override or methods, and it can either be protected or private, so it's not public. The subclasses of a sealed class, if you want subclasses, must be in the same file. So let's create another class called owner, and this is going to be within the same file because we want to make it a subclass of booking. Make a value of ID, it's going to be int. As a plane passes by my house, you're going to hear that a lot during this series. But then it's going to be booking because we're inheriting from it. Then we're going to make another class called resident, and this is also going to be a subclass, so it has to be within this class. And I want the name and the room number. And it's going to be int. And it's going to inherit from booking. And now we're going to make an object for non-residents. So guest. And this is going to inherit from booking. Alright, so a sealed class really shines when we start using when expressions. Because of the restrictions set by a sealed class, we know what to expect when we use a when expression with a sealed type. The compiler will get angry if a parameter not handled by the when is added. So with a sealed class, we should know what to expect because of the restrictions, especially with everything by default being private and protected. So let's make a when expression. So let's call it fun, and let's call it front desk. And E with the type booking, and we're gonna make it return an int where that wants to return the ID or room number based on the booking. So if we have an instance of owner residence, we can return the ID of the owner, or we can return the residence room number. And if it's a yes, then we'll just throw like 0, meaning that they're a non-resident or they're not even the owner of the establishment. So let's do that. Let's create a when, and we're going to take in the value from the function, and we're going to open up this one expression, and it's going to be if it is owner, then we can return e.id, because that is the value that we're passing into owner, so we should have an instance of that, because if it is of type owner, then e would be able to retrieve the ID. And is resident, it is a type of resident, so because we have an instance of room number, we can do e.room number. Then the last type of booking that we have is non-resident. And before I do that, let me just erase that. What's the error I was saying besides this? Yeah, see, look, it says one expression must be exhaustive. Add necessary non-resident branch or else branch. So it gives us the option whether we want to use else or we want to use all the possibilities of booking, because everything has to be within this class, so it knows exactly what needs to be used. It doesn't expect any outside influences, because anything that inherits from booking has to be within this class. There's so many restrictions with the subclass, so that's where this really shines. So now for the final case, it's non-resident. If it is non-resident, then we'll just return 0. So now when is not angry, because we don't even need an else, because we exhausted all possibilities of this expression. So now when the front desk passes in the booking type, it will check whether it's the owner. If it's the owner, it returns the ID. If it's the resident, then it'll return the room number of the resident. And let me remove this comma. And if it's a non-resident, then we just return 0. They're just a guess. So this is a sealed class. If you want things to be restrictive, no constructor or primary constructor, you can still have a constructor, but it's going to be protected or private. And you want to use, let me take this other comma out. It's a habit. But if you want to have a specific or restricted class, this is perfect. Of specific types and subclasses, that's going to be all within one class. So hope you guys enjoyed that. Alright, so in Kotlin we have a thing called a Singleton object. A Singleton object is an object that has one instance for the entire project. For example, we may use a Singleton object to store utility methods to use throughout the entire application, and you do not want to create a new instance every time just for helper functions. So we don't have to recreate an object or create an instance of an object like employee for Giovanni and Jim and all that. We can just have one instance of that object for the entire application. So this is perfect for things like utility objects, which have helper functions that can be used from throughout the application. So let's create one for management. We'll have this new utility object, Singleton object, and we're going to call that building util. Go down to object, and now we have a Singleton object, and now we can start creating some properties that we can use from anywhere. So now let's make a property that holds the rent amount for a standard rent fee. So let's do eval standard fee, and it's going to be a double. We're going to make this equal to 1,000. And what is this swiggly saying? Property standard fee is never used. We are going to, then we're going to make one for deluxe. So eval deluxe fee is double. Oops. And we're going to make this double actually. So we're going to make it 2,000. Perfect. Now what if we want to return a value for the amount that rent will cost for a year, or a certain amount of months? we'll have a parameter that taking the amount of months that we want to see, and then we'll return the value times that, type. So we'll just do fun cost of deluxe per, or let's do rates, deluxe rate. And then we're going to take in the months as the parameter, and we're going to do int, open it up, and then we'll just return rent amount times it by the months, or my bad, deluxe fee. And we're gonna make this return a double, and that's only if months is greater than 0. So we don't want anyone passing in, negative value that will cause problems. So we'll have that check. I forgot to put a open brackets right here, or curly braces right here, and then we can have an else, and return 0 if anything else. So perfect. If the month is greater than 0, so I'm assuming 1, then we can just return deluxe fee times the amount of months. If not, then we'll just return 0.0. Or you could just return an exception or throw an exception, but in this case I'll just return 0. And we'll do the same thing for the cost of the standard fee. In a realistic scenario, you'll probably have a list, and then you just check for the type, but we'll just do it this way. And then cost, and then months, and then standard fee. So now we have two functions. We have one that return the deluxe rate based on the amount of months that you intend on staying, and then the cost of the standard rate depending on the cost or the months that you intend on staying, and we'll times that against the standard fee. So now we have a building utility Singleton object, and now this is going to be used from anywhere, or can be used from anywhere within the application. So let's go into our main, and we're just going to comment all this out again, and then let's print out, what if we want to stay, or actually, first of all, let's make this private, by the way, because we don't want this to be changed from the outside. We only want it to be seen within this building util. We should only be able to change the rates, nobody else. So then we just go into this println. Now we make a call to the object. We don't have to create an instance, but we can just take a reference of the building util, and then use dot notation to see what we have inside of building util. And we can see the cost of the deluxe rate and cost of the standard rate. I want to see how long or how much it will cost to stay at a deluxe room, or in a deluxe room, for 12 months. Now let me see, let's put this in string notation, or string template, and make a nice little prompt. So the deluxe rate to stay for 12 months is, and then put a little $, and then close that, and then actually put an actual $sign in front of it, so $2. And then we should be good to go. So now we know, or now we can see how much it will cost to stay at our apartment or hotel or whatever building for 12 months using the utility object. Boom. So to stay at a building at a deluxe rate, it will cost $24,000. 12,000, or 12 times 2,000 is 24,000. Quick maths. And I just copy that, and we'll do the same thing for the standard. that's going to be 12 months. The standard rate to stay for 12 months is, and then let's see how much that would cost. It should be half, so 12,000. So isn't that cool? Like, we don't have to create a new instance of a class to get some functionality. We can create a singleton object that is the same throughout the whole application. We only have to make one instance of it, and we can just reference it by using dot notation, and we can have access to whatever utility functions that we need or that we created. So this is perfect. And we do have the option to inherit. So we could, we're not gonna do this, but look, we have the option to inherit if needed. We can pass in the market price, but obviously in this case it wouldn't be it wouldn't make sense to inherit from building. But if you do have a management class, we can create a new management class and inherit from management, and maybe they have their own implementations that we need to inherit or override, such as maybe management have a discounts functionality, maybe place contacts inside of it for executives or management or other hotels or buildings. So things like that. You just use your creativity, build those relationships, and just code. So in Kotlin, if you want to create a function or a property that can be called without the instance of the class, you can use a thing called a companion object within the class. So by creating a companion object, you can access the properties by only using the class name. So let's see this in action. You already have an instance of office building right here. Let's go into office building and let's create a companion object. So to create a companion object, you use the keyword companion and followed by the keyword object. And now we can just open up some brackets. We could give it a name, like boss, or boss man, or data, but it's not necessary. It's optional, and usually I don't put a name. So now we have our own space to start, declaring some properties or a method or function that we can call without having to make an instance of this whole office building class. So in a realistic setting, like when I'm working and I'm using Kotlin, this is usually where I put my logger, or I might put some constants in here, and I can just retrieve the constant if need be, or I can have an instance of that logger. But for now, I'm just gonna make a simple function called office building prompt and put parentheses, and I'm gonna make it equal to welcome to the office building. Oops, that is not equal. So now I want to make a call to this office building prompt. It's just gonna return welcome to the office building. So let's go into the main, and I have an instance of office building right here, but it's not necessary when using the companion object because we don't need an instance of we don't need an instance of the class to use things within the companion object. We just got to use the class name itself. So let's do a println, and let's get office building, which is the name, and then we can do office building prompt, which if we go back to office building is within the companion object. And if we run this, boom, welcome to the office building. And like I said before, even sometimes you can define constants in here. So we can just do const file. I'm just gonna make this pi, or let's see what's something that's important. You could do like, I don't know, like square feet or something, but I'm just gonna do something ridiculous and just do pi 3.14. And if I want to get that, then I can just do office building pi, boom, and I print that out. So if you want to give access to something that doesn't require an instance of the object itself, then you can just place it inside of the companion object, and all you would need is to use the class name and some dot notation, and you'll be able to retrieve things within the companion object. So just think about it. In real world scenarios, you can use that to put in your logger, define some constants, and stuff like that. Something that you want to be accessible. So Hope you guys understand what a companion object is.